According to Einstein, space-time is like a fabric, and what we call gravity is the warping of this fabric by a massive object, like a star. A planet orbits a star when it's caught in this warped space, like a ball spinning around a roulette wheel. It's an astonishing idea, and it led Einstein to a prediction that when a massive object collides with another, or changes speed or direction, it produces waves in the fabric of space-time. Gravity waves.
This is what happens to space itself. It stretches in one direction and it compresses the other. It collapses up and down and it stretches sideways. And here's a gravity wave at a certain frequency. The frequency is once a second or something like that. That's what it does.
To measure this stretching and squeezing, Ray turned to a device called an interferometer. A laser beam is split and sent down a pair of long perpendicular tubes, each precisely the same length. The two beams bounce off mirrors and recombine back at the base. The light waves come back lined up in such a way that they cancel each other out.
And you add them together, you get nothing. You get a zero, a big fat zero. No light gets detected at the photodetector.
But when a gravity wave comes along, it distorts space and changes the distance between the mirrors. One arm becomes a little longer, the other a little shorter. An instant later, they switch. This back and forth stretching and squeezing happens over and over until the wave has passed. As the distances change, so does the alignment between the peaks and valleys of the two returning light waves, and the light waves no longer cancel each other out when added together in the recombined beam. Now some light does reach the detector, with an intensity that varies as the distance between the mirrors varies. Measure that intensity, and you're measuring gravity waves.